Hello, this is paper 1, Math HL IB diploma, and the first problem is telling us that we have an arithmetic sequence in which U5 is equal to 6 and S12 is equal to 45. Remember, for an arithmetic sequence it has the property that each term is the previous one to which we add the same number called the common difference, D. So U2 is U1 plus D, U3 is U1 plus 2D, U4 is U1 plus 3D, etc. Therefore, the general formula is that UN is U1 plus n minus 1D. And the sum of the first n terms is n over 2 into 2U1 plus n minus 1 d. Now we apply the formulas for our data, and we have the first one for n equals 5. We have u5 equals u1 plus 5 minus 1 4 times d equals 6. And the second one we apply it for n equals 12. So we have s12 equals 12 over 2, 6 into 2u1 plus 12 minus 1, that is 11, times d equals 45. We can divide this equation by 3 on both sides. We can make u1 subject of the formula and we replace it in the second equation. Therefore, we obtain 6 divided by 3, 2 into 2u1 plus 11d equals 45 divided by 3, 15. So 2 into, instead of u1 I write 6 minus 4d, so that will be 12 minus 8d plus 11d equals 15. So 2 into 12 plus 3d equals 15. 24 plus 6d equals 15. 6d is equal to 15 minus 24, that is minus 9. Therefore, the common difference is minus 1.5, minus 9 over 6. We replace in the expression of u and we obtain u equals 6 minus 4 times u1 minus 1.5. That will be 6 plus 6 equals 12. Now let's do number 2. In number 2 we are told that the sum, the mean time of 3 skiers in a competition is 34.1 seconds. The mean time is S1 plus S2 plus S3 divided by 3, where S1 is the time of the first skier, the time of the second one, and the time of the third one. So the mean time, we take the sum of the times and we divide by 3, is 34.1 seconds. And we also know that if we add a fourth skier, a fourth one, the mean time becomes 35 seconds. So S1 plus S2 plus S3 plus S4 over 4 equals 35.0 seconds. And we are asked to find the time taken by the fourth skier. Now, from the first equation, S1 plus S2 plus S3 by cross multiplication can be written as being 34.1 multiplied by 3, which equals 102.3. So we replace in the second equation S1 plus S2 plus S3 by 102.3 equals 35.0. Therefore, we have 102.3 plus S4 equals 35 times 4, 35 times 2, 70 times 2, 140. So the time taken by the fourth skier is 140 minus 102.3, that is 37.7 seconds. The question is quite straightforward. Number 3, we are told that the diagram represents the equation of a function of the form a sine b into x plus c plus d. And we are asked to find the values of a and d. So we know that a is the amplitude of the function, the amplitude, which is the maximum value of the function, take away the minimum value, over 2. That is, the maximum value is 3.5 minus 0.5 over 2, that is 1.5. And D is the horizontal symmetry axis, is midway between maximum and minimum. So is maximum plus minimum value over 2, that is 3.5 plus 0.5 over 2, that is 2. In the second part, we are asked to find the value of b. Now we know that, for example, if I have an equation, a function of the type y equals sine 2x, the fact that the argument is multiplied by 2, it means that all the x coordinates are being divided by 2. So it's a one-way stretch along the x-axis by scale factor 1 over 2, meaning that the period of this function is equal to the period of the sine function 2 pi over the 2. Therefore, for my function, the period will be 2 pi over b. Now, looking in the drawing, we can see that the period has length 2, because it repeats itself after interval of 2. So we have 2 equals 2 pi over b. We can divide by 2 both sides. Pi over b equals 1. Therefore, b is equal to pi. And for the third part, we are told that c is greater than 0. Therefore, my graph has been translated to the left in the negative x-axis direction. Translation to the left. And when I look at where the sine function should start, it means that c, the translation, has been done by 1.5 units. So c equals 1.5. Number 4, we are given a Venn diagram and we are asked to shade the region representing A dash intersection B dash. In words, A dash means everything that is outside A. I will color it, I will shade in red everything that is outside the set A. That's it. Outside A, here as well, we avoid A. And B dash means everything that is outside B. I will use blue shading for whatever is outside B. So I'm going to avoid everything that is inside B I will shade only outside B. Intersection means whatever is common between A dash and B dash. That is where we have two types of shading. As we can see, it is outside the circles representing A and B. In other words, the final answer is set A, set B, and we are going to shade everything that is outside A and B. Now for the part B, for the second part, we are given that probability of A intersection B dash is 0.2 and probability that A union B is 0.9, and we are asked to find the conditional probability of A dash being given B dash. So I will draw again the Venn diagram, and we see on it, oops, I shall erase the region outside. So this is the set A, this is the set B. So A intersection B dash, intersection means common. So what is common between A and outside of B? That is, what is inside A and is outside B. It means this region. So this region is represented by the probability 0.2. Probability of A union B equals 0.9. It means I shall shade in red everything that is together, in magenta, everything that is together A and B. So that's it. So all this magenta area is 0.9. From the drawing we can see that probability of B is probability of A union B 0.9, from which we remove this region, that is probability of A intersection B dash 0.2. So probability of B is going to be equal to probability of A union B, the two circles, take away probability of A intersection B dash. It can be seen. If I take away, I am left only with the probability of B, only with the strictly with the magenta area. So that will be equal to 0.9 minus 0.2. Probability of B is equal to 0.7. Therefore, probability of B dash is 1 minus 0.7, because probability of B plus probability of B dash is a certain event, 1, that is 0.3. And now we write the conditional probability formula. Probability of A dash being given B dash, probability of A dash intersection B dash over probability of B dash. A dash intersection B dash is shaded in the first part, so is everything outside the union. Now, being given that the probability of the union is 0.9, probability of everything that is outside the union, which I draw here dotted, will be 1 minus 0.9, that is 1 minus 0.9, 0.1. And probability of B dash calculated here is 0.3. That will be equal to 1 minus 0.9, 0.1 over 0.3, that is equals 1/3. For number 5, the first part, we are asked to expand 1 minus square root 3 to the square. So binomial to the square, it will be 1 squared 1 minus 2 times 1 times square root 3 minus 2 root 3 plus square root 3 to the square, that is 3. 1 plus 3, 4 minus 2 root 3. In the second part, we are asked to find cos 15 degrees, writing 15 as being 60 minus 45. According to the formula, cos 16 minus 45, remember, is cos 16 degrees, cos 45 degrees. In sine, minus would stay minus, and for the cos formula, minus becomes plus. Sine 60 degrees, sine 45 degrees. And remember, the cosine of 60 degrees, 1 over 2 times cos 45 square root 2 over 2 plus sine 60 degrees square root 3 over 2 times sine 45 degrees square root 2 over 2. Common factor square root 2 over 4 into 1 plus square root 3. For the third part, we are given that AB is 2, AC is square root 2, and the angle A is 15 degrees. So we know two sides and the angle in between and the angle A. Therefore, we can apply the cosine rule. And the cosine rule says that BC squared, the third side, is equal to AB squared plus AC squared minus 2 times AB times AC times cosine of the angle A. So BC squared will be equal to 2 to the square plus square root 2 to the square minus 2 times square root 2 times cos of 15 degrees is square root 2 over 4 into 1 plus root 3. That will be equal to 4 plus 2, 6. 2 times 2, 4, we simplify. Square root 2 times square root 2 is 2. So 6 minus 2 minus 2 root 3, which will be equal to 4 minus, the 2 can get under the square root as 4. 4 minus square root of 12. Therefore, BC will be equal to square root of 4 minus square root 12. We remember the formula for the composed square roots. A is 4, B is 12. Therefore, C will be square root of A squared minus B, that is 16 minus 12, square root 4, which is 2. So BC will be equal to square root of A plus C over 2. We have minus here, therefore we use minus square root of A minus C over 2. So that will be equal to square root of 4 plus 2, 6 over 2 square root 3 minus square root of 4 minus 2, 2 over 2, 1, that is 1. Number 6, we have that m, we have to find the integers m and n such that m minus n log base 3 of 2 equals 10 log base 9 of 6. So we can see that we don't have the same base for the logarithms. Therefore, we have to change the base. Log base 9 of 6, for example, I will write it as log base 3 of 6. I change the base from 9 to 3, divided by log base 3 of the old base, log in the new base of the old base, which equals 9 is 3 to the square. Therefore, log base 3 of 3 to the square is 2. So that will be log base 3 of 6, everything over 2. So my equation becomes m minus n log base 3 of 2 equals 10 times log base 3 of 6 over 2. We simplify, we are left with 5. So m equals, we move n log base 3 of 2 to the other side, we change the sign. That will be 5 log base 3 of 6 plus n log base 3 of 2. Therefore m equals 5 gets inside as a power, log base 3 of 6 power 5 plus, in the same way n gets inside, log base 3 of 2 power n. Therefore m will be equal to log base 3 of 6 power 5 times 2 power n. According to the laws of logarithms, log a plus log b in any base is equal to log of a times b. M can be written as log base 3 of 3 power m equals log base 3 of 6 power 5 times 2 power n. Log base 3 cancels out because the log function is injective, it means the arguments are equal. Therefore 3 power m equals 6 can be factorized into 2 times 3 to the power of 5 times 2 power n. Therefore 3 power m equals 2 power 5 times 2 power n times 3 power 5, or 3 power m equals 2 power 5 times 2 power n to power n plus 5 times 3 power 5. On the left hand side we don't have 2 to any power, so it's as if we imagine we have 2 power 0. Therefore m and n being integers, we obtain that n plus 5, we create the powers of 2 must be 0, and we create the powers of 3, m must be 5. So m is 5 and n will be equal to negative 5.